No, Miss Bryant was out a couple weeks ago. Yeah, and then I've done all the periods before, but this is the first time I've taught all the classes without Miss Bryant because intermediate was testing last time. But anyways, yep, so the first thing we said to do on this problem was we were going to leave our right-hand side alone. That left-hand side, we want to rewrite it in terms of cosine and sine. So tangent squared is going to be exactly sine squared over cosine squared. And then do we need to rewrite sine squared? Nope, it's already a sine or a cosine. So now we have a fraction minus not a fraction. Whenever we see that, I would always just think to myself, okay, let's make it a fraction minus a fraction, because I know how to add or subtract those. So you can just set sine squared theta equal to sine squared theta over 1. From there, I got to think back to myself, okay, so I know how to add and subtract fractions, and the way I do that is I need a common denominator. One way to think about a common denominator is you can just multiply by the denominator of the other one. But multiplying by 1 over 1 isn't going to do anything. So the only thing we need to multiply is we need to multiply the sine squared theta over 1 by cosine squared theta over cosine squared theta. So I'm going to give us a little bit more room. Yep, so the second term would multiply by cosine squared theta over cosine squared theta. I would say, kind of looking at people, pre-calc peeps' work in other classes, a lot of times they were tempted to just kind of keep working across their page. When you're doing these verification problems, once you get an equal sign, rewrite it below. That's just kind of standard practice. It makes it look cleaner, it's better organized, all of that. So now, we have a common denominator. We are allowed to subtract across the numerator, and the denominator is just going to be our common denominator. So what's the denominator going to be?
Cosine squared theta.
Yep. Our denominator is just going to be cosine squared theta. And our numerator, this is where you have to be really careful. It's going to be sine squared theta. Yep. Minus, you do not drop that minus sign, minus sine squared theta times cosine squared theta. One thing that you have to remember is that these two terms, since they're being multiplied, one way to think about multiplication is those two terms are stuck together. You can't just decide to say, okay, sine squared theta minus sine squared theta is 0. You cannot do that. And the reason you can't do that is you would be breaking PEMDAS. Multiplication comes before subtraction. So what you would need to do is think about it as this term, and then as this term minus this whole term. And those aren't like terms, so you can't just subtract and cancel. But what you can do is have the awareness to think, I see an identity. Who sees the identity that I see? Anybody? Do you see anything on your pink sheet? Or do you see anything that looks close to an identity? Yeah, sine squared and cosine squared. And this is where you have to be really careful. What does it exactly say on the pink sheet with sine squared and cosine squared? Sine squared plus cosine squared. So here, I have alarm bells. I see a sine squared and I see a cosine squared. I'm thinking, okay, it's going to be an identity. But to be an identity, it has to exactly be an identity. Here, we have sine squared times cosine squared. That is not the same thing as sine squared plus cosine squared. It's multiplication, not the addition that that identity requires. So we cannot just substitute in 1. What we can do is see that both terms in our numerator have a sine squared. They have a common factor. So when we see that, we can factor out a sine squared theta. When we do that, whatever our GCF is, we divide each term by it to see what's going to be inside our parentheses. Sine squared divided by sine squared is 1. Sine squared times cosine squared divided by sine squared is just going to be cosine squared. And it's still going to be all over cosine squared theta. From here, now do you see an identity that exactly matches the pink sheet?
Yeah.
So the 1, remember, we took the GCF out of the whole top. When you take a GCF out, we had 2 terms. We had sine squared, and we had minus sine squared cosine squared. You better have 2 terms left in the parentheses. Sine squared minus sine, or divided by sine squared is 1. So that's where that came from. Negative sine squared cosine squared divided by sine squared is just negative cosine squared. Great question. You guys are pretty locked in this morning. So yeah, the identity is what I wrote in blue. 1 minus cosine squared. What's 1 minus cosine squared? Sine squared, exactly. So now we have sine squared theta. Give myself some more room. Yeah. Sine squared theta times sine squared theta all over cosine theta. Now, I would say, I know there's a lot of things to remember, but I would say as you're doing these problems, always keep what's on the right-hand side in the back of your head. Because if I were you and I wasn't paying attention to the right-hand side, I might say, okay, I can get sine to the 4th theta. But then you'd get stuck. And what I'm saying is, we need a sine squared theta in our answer. So one of these sine squared thetas, we need to keep out. And that's one way to think about it. We need one of these sine squared thetas to stay a sine squared theta. So you can almost think about it as that portion in the blue, I just need to kind of keep that out of it because that's going to be in my answer. And you can also see that in our answer, it's tangent squared theta times sine squared theta. We can rewrite this fraction, and it might be tricky to see if you haven't seen a problem like this, but we can rewrite this fraction as sine squared theta over cosine squared theta times sine squared theta. You can rewrite, I should have a bunch of equal signs down the whole page, but you can rewrite that fraction like that.
Do you need to have a cosine over the other?
Nope. And think about it. If you multiplied these 2 things together, you would end up with that fraction. That's always a quick way to make... Yes.
Okay.
If you're not sure if you were following the rules, work backwards. Like, undo what you just did and see if it works out. If you're unsure if you can just pull out that sine squared theta from the fraction, multiply it back in. If you multiply it back in, you would get sine squared times sine squared over cosine squared. It's really just stressing and seeing if you know your algebra rules. From there, we know we're searching for a tangent squared theta. What's sine squared theta over cosine squared theta? Tangent squared theta. So the last thing you would write, geez, I need a lot of page, is just tangent squared theta times secant squared theta. And lo and behold, that equals exactly the right side. And we are good. We have verified it. One tip that I have. Yes. You can do that. And the reason you can do that is, let's do some work on the side. What is 1/4 times 5. 5/4. So we can rewrite 1/4 times 5 as 1 times 5 over 4. When you're multiplying in the numerator, you can take, and it's only multiplication, you can take one of those factors out of the fraction. That's a completely legal move. If you're someone who really likes to think of math as just hard, fast facts that you just have to learn, that's one of the hard, fast facts. That's just a rule that you can do when you're algebraically manipulating fractions. Anyways, you might not have seen that move unless you did something like this at the beginning of your problem. And this is a strategy. So one of the big rules about verification is we don't touch the right side. And that's correct. We do not touch the right side in kind of our formal work when we're working down the page. But you can help yourself out by kind of writing a side note on the side. And that side note on the side, that's a little redundant, is you can take your right-hand side and rewrite it in terms of cosine and sine, just off to the side. So if I was rewriting the right-hand side in terms of cosine and sine, I would have seen that the right-hand side was actually sine squared theta over cosine squared theta times sine squared theta. And the reason you would do this, just write it off to the side, is because then, as I'm going through my work, what I'm really trying to get to is that. Because think about it. Originally, we made everything in terms of sine and cosine. So in order to get our final answer, that's going to be the second to last step. It's going to be our final answer in terms of sine and cosine. So we still don't touch the right-hand side during our work. But if you want to make a little note, a little goal off to the side of what it should look like in terms of cosine and sine, do that. It can only help you. Because if you had in your brain that you were looking for sine squared theta over cosine squared theta, it might make more sense when you see that to say, oh, I just need to pull this sine out, and I'm in good shape. If that kind of strategy confused you, don't worry about it. Just keep doing it the same way. But if you're finding yourself stuck right at the end of these problems, maybe make a note off to the side of what the right-hand side would look like in just terms of cosine and sine. Any questions with the bell work? Great. So we don't have a ton of problems today. The goal is to give you guys more time to work on your homework. I think we have this one. Yeah, we have 2 problems to get through. And this is the first one. So you don't need to write down 1 and 2 again. You should already have that in your notes. Just write down the problem. Are we going to have to apply number 1 in this problem? Keep writing, but are we going to have to?
No.
No, because we're already in terms of sine and cosine. I think when we have to add fractions, so it's a problem type like this, it might be the most difficult verifications we can give you. The good news is, usually when we do that, it's already going to be in terms of sine and cosine. Lance, when we're adding fractions, what do we need? Common denominator. So what am I going to multiply that first fraction by? Sine over sine, yep. What about that second fraction? 1 plus cosine over 1 plus cosine. Great. So after you copy down this problem, your first step, which should be establishing that common denominator. I would try it by yourselves and then just use the board for reference. Don't just copy down what I'm writing. It's so important for these that you get the experience of doing it by yourself. Once you get to where I've gone on the board, where you've ran out what your common denominator is going to look like, take it a step further. See if you can add those together. Eyes up on the board real quick. The big thing to remember is that sine is multiplying with sine. 1 plus cosine is multiplying with 1 plus cosine. This is a box problem right here. Floyd, however you want to think about it. You are not right here just going to say this is 2 plus cosine squared. You have to take the cross terms as well.
Yes, good. That was your last turn, would it be? Good, very good, very good. Now, think this whole numerator is just an addition. You can switch up an order of addition to get one of your ends. Where are we at, Griffin? Okay, so there should be, you're very close. There should be plus there should be cosine. Oh, okay. So you needed to multiply the top by the same thing as the bottom, so 1 plus cosine x. which is what you did there. Okay. So now there, it should have been 1 times 1 is 1. Cosine times cosine is cosine squared. 1 times cosine is cosine. 1 times cosine is cosine. So it should have been plus 2 cosine x. Very, very good stuff.
Don't be afraid to use the box if need be. Yes, good, good. All right, so after this is what it should look like. That's what that big nasty thing looks like together. You could have done it with a box, but if not, you see this, 1 times 1 is 1. Cosine times, so those are the firsts. Last, cosine times cosine is cosine squared. And then you have to do your cross terms. 1 times cosine is cosine. 1 times cosine is cosine. If you need to visually see that with a box, do a box. So we ended up with 1, 2 normal cosines, and 1 cosine squared. That's how I got that. From here, I'm going to grab the iPad so the recording can hear it. From here, this numerator, eyes up, I'm using the highlighter. This numerator is one big addition problem. 4 plus 5 is 9. 5 plus 4 is 9. Well, the fancy math term for that is that addition is commutative. It doesn't matter the order that we add things. I'm saying that to say this. We can rewrite this fraction as sine squared plus cosine squared plus 1 plus 2 cosine x. What's sine squared plus cosine squared? What? 1. That's one of our identities you need to know. Sine squared plus cosine squared is 1. It's okay that they aren't next to each other. As long as it's all addition, you can flip the order. So now we have 1 plus 1 plus 2 cosine x in our numerator. What's 1 plus 1? 2. So we really have 2 plus 2 cosine x. I'm just going to let the denominator hang out. You could distribute it if you wanted to. I'm just going to let it hang out for now. Sine x times 1 plus cosine x. So now, what do you think we're going to do in the numerator? It's very similar to what we did in the last problem. Yep, we're going to take out the GCF. What's my GCF? 2, exactly. The GCF is 2, we're going to take it out. So then the numerator turns into 2, and then 1 times 1 plus cosine x. I would say, just kind of the pattern of these problems, when you find a common denominator to add fractions, leave that common denominator factored. Don't just like here, leave it as sine x times 1 plus cosine x. Because a lot of times, something like this is going to happen. Exactly. On the top, we have 2 times 1 plus cosine x. On the bottom, we have sine x times 1 plus cosine x. Because both of these are being multiplied, we can cancel them, even though there's addition inside the parentheses. The fact that they're grouped together by parentheses means they're just all one big ugly term that we can cancel. So now we have 2 over sine x. When we're simplifying, one of the things about simplifying, I know this is a verify question, is that we need to get our trig out of the basement. What happens when we get trig out of the basement? Yep, it turns into its sister. So here, we can rewrite 2 over sine x as 2 cosecant x. Lo and behold, we have our answer. We are good. You would just rewrite that down there, circle it, and say we verified. There's only so many patterns we can throw at you. So when you're new to these problems, It's probably like drinking out of a fire hose. It's just like, what is going on? But once you start seeing these patterns and being able to identify, oh, I need to do a GCF up top. Oh, I need a common denominator. It becomes way more simple and way easier. And that's why doing those homework problems is so important. So here's the last problem we'll do together today. Do we need to rewrite this one? I see a yes and a no. Why no?
Well, I mean, it's very, never mind. Yeah, it's not inside.
And this is where a little bit of the number sense component comes into play. You could rewrite this in terms of cosine or sine. But let's stop looking at our sheets real quick and look up here. And let's look at this problem. What we're trying to find is 1 plus cosine squared theta. We're trying to find an addition problem, which is pretty rare for us. Normally, we're trying to find like multiplication or whatever. So we might not necessarily want to get rid of this addition. In fact, we might be looking for something where we would want to break this apart. And I know that might be difficult to hear, but think about this. If we have a fraction, say we have 3 plus 4 over 5. What's 3 plus 4 over 5? 7 over 5. But it's also the same thing as 3/5 plus 4/5. That makes sense to us. We can break fractions over addition in the numerator. Not the denominator, but the numerator. We can break fractions. So before we think about rewriting things, we know that right now we have kind of one fraction. We know that in our answer, it's something plus something. We have two separate things. So let's see what happens when we break up this fraction. When we break up this fraction, we're going to get 1 over secant squared plus secant squared over secant squared. Holy cow, that looks pretty simple. What's 1 over secant squared? Cosine squared. Cosine squared. When you bring something to the numerator, it turns into its sister. The sister of secant is cosine. Sister of secant squared is cosine squared. What is any number in the universe divided by itself? 1. I know it's a trig function, not a number, but secant squared over secant squared is 1. I guess the only number that's not true for is 0. Secant squared ain't 0. Secant squared, secant squared. So secant squared divided by secant squared is going to give us 1. Now all we have to do is reorder it to make it look exactly like the right-hand side. And we're done. Now, if you're like Mr. Suchi, I would not have thought to do that first step. That's okay. That's why we are showing you this problem. The whole time we are working with these simplify and verify things, there's going to be some new patterns. And that's all right. If you had broken up this fraction and it didn't get simple, that's why you have an eraser on your pencil. We have erasers for you. You can erase and go back and think, okay, let's break it into cosine and sine. And if you had broken this into cosine and sine, you would have been able to simplify. We'll talk about it. I'm not going to show it because it kind of would take about twice as much work as what I just showed. But it'd be 1 over 1 plus 1 over cosine squared all over 1 over cosine squared. When we have a big fraction like this, we want to be able to keep, change, flip it. So what we would have had to do is find a common denominator in the numerator. because we can't keep, change, flip until it's one fraction over one fraction. This would have been two fractions, so we would have had to combine them. And then keep, change, flip, things would have canceled, you would have got the same answer. But if you have that number sense to think to myself, okay, I see big picture one thing on the left-hand side, two things on the right-hand side, but I know how to turn that one thing into two things. Because I know I can break fractions with one denominator over addition. Play it out. Here, it got really simple, really fast. So for the rest of the time, you guys are expected to be working on your homework. Homework 9. It is due tomorrow. Obviously, you can turn it in Monday. If you have a question, call me over. If you have a question, also just see if one of your classmates is maybe working on the same one. It can be super, super helpful on these problems to just talk about it with someone.